In this video, we are going to discuss about classification of signals and systems. So first, let us discuss about the classification of signal. So what is generally a signal? A signal is defined as a physical quantity which varies with time, space, or any other independent variables. So for example, you have a the one-dimensional signal, like example like speed signal, power supply signal, right, and ECG and EMG, EEG, and you can see there is a variation in the temperature. Also, you can plot it in the one-dimensional signals. Okay, there are also two-dimensional signals. Examples like X-rays. That is, it will vary with respect to two independent variables. There is also a multi-dimensional signals which vary with respect to multiple variables. So let us discuss about the classification of signal. First one is even and odd signal. Second one is energy and power signal. And third one is causal and non-causal signal. So what is causal signal means, here the h of n value is equal to 0 for n is less than or equal to 0. That is called as causal signal. And for non-causal signal, h of n value should be less than 0 for n is equal to n less than or equal to 0. So here I can, instead of h of n, you can use y of n or y of n, okay, because y of n is nothing but your response. X of n is represented as your input, and h of n is represented as a system. So basically you can use y of n or h of n for this one. Okay, there are another classification is continuous time and discrete time signal. So continuous time signal is represented as x of t, and discrete time signal is represented as x of n. So the continuous time signal is defined for every instant of time t. So you can see for every instant, for 0, 0.1, 0.2, 0.3, like even for minus 0.1 also I'm getting the values. Whereas for discrete time signal, it is defined for a discrete period of time. Okay, so it is not represented um, for n is equal to 0.1 or 0.2 or any decimal point values. So you can see this diagram. So here the n values ranging from 0, 1, 2, 3, 4 up to infinity, right? So the 0 might be any values. I can take the example as 1, 2, 1, etc. Okay. In a similar way, I can represent it at minus 1, minus 2, and minus 3. So I can't predict the value at minus 1.5, minus 2.5 and all, because since n value is always integer value. Okay, so you have to note it down, this one. Okay, so basically if converting analog to digital signal, we require this type of signal. Okay, so you can see for n is equal to 0.5, we don't know the values. All right, so this is nothing but discrete type signal. Okay, so there it is not a continuous one. Okay, so you can see this is like so the amount I'm going to deposit at the first month, second month, third month, fourth month, like this. If I predict that one, I can plot the graph like this, right? The sixth one is deterministic and random signals. So what is generally a random signal? So it is nothing but its value is uncertainty. That is, if you see the noise means we can't predict the value at any instant of time at t is equal to at time t, right? So this is how the signal is. So I can't predict the values using the help of the mathematical equation, right? So whereas if you see the deterministic signal, we can easily predict the values with the help of mathematical equations. So I'm going to take this example for this one is u of t, a sin cos t, right? So the A may be of any values and sine omega t, like that. Okay. So, and it is also, it is not having any uncertainty, because at any value of time we can predict the values, right? The amplitude values I'm telling. So in the first unit, you're going to study about what is types of signals and what are the types of systems, and you will get most of the problems in the first unit, classification of signals and classification of systems. So this is a very important question. Okay. So it can be predicted by using the help of the mathematical equations. So you can see all the periodic signals are comes under the deterministic signal. So what is a periodic signal? X of t is equal to x of t plus capital T, right? But I can't tell the deterministic signal is all the deterministic signal as a periodic signals. Next one is classification of systems. So I can term the h of t is as my system, and x of t is my input, and y of t is my output. Okay. So that I can write y of t is equal to x of t into h of t. So here the t represents, it is a continuous time system, right? So where h of t is equal to y of t divided by x of t. So here this is h of t is called as a transfer function. Okay. So the first type of system is static and a dynamic system, right? This is also called as a memory-less and memory system, right? The second one is called as a causal and non-causal system, right? So the causal values depends on the present and past value. Non-causal is future. If it goes to future, it is a non-causal system. And third one is a linear and non-linear system. So it has to satisfy the two conditions, right? The fourth one is nothing but a stable and unstable system. So it has to be bounded input and bounded output, the input and output. And the fifth one is nothing but the continuous time and discrete time systems, right? So I told you the discrete side system is it has to be h of n, right? And the continuous time system means x of t, h of t, like that. You must have. So here the y of t is equal to t into x of t. So I represent h of t as capital T. So likewise, you can term the discrete time systems like this. Uh, so here the input and output both are the continuous one. For discrete time system, input and output is a discrete time signal, right? So the next one is time variant and time invariant system. So if y of t is equal to y of t plus t minus t, capital T, it is a time invariant system. So if it is not, it is a time variant system. Okay. The last one is lumped and distributed parameter system. You have one more system which is called as invertibility and inverse system. Okay. So I hope this video is useful for you. Thank you very much.